So when b and c are 0 in a quadratic, it's actually very easy to solve, because you can see we have x squared equals 0, so x is just equal to 0. They're the only roots. And you can see no matter what a is, let's say a was 6, you can just divide both sides by 6, and then still x squared is equal to 0, and that's it. You can see it only crossed the x-axis at 0. It's not super interesting. Then when we add c, which is just a constant, that just shifts it upwards or it shifts it downwards. Obviously, if we shift it upwards, there are no solutions. You can see it never crossed the x-axis. There's no point where y is equal to 0. It's imaginary. But when c is negative, you can see it's quite easy to solve. Let's say we had 9, right? And I'll just go back to 1x squared just to make it easy. You can see we have 1x squared equals to 9. We just bring the 9 to the other side, so x is plus or minus 3. And you can see here, so it's minus 9 there, so our answers are minus 3 and they're plus 3. It's kind of symmetrical. It's 3 on each side, 3 units to each side. So that starts to get difficult when we bring in a b term, because then it shifts it across to the side, and there's kind of nothing we can do once you shift it to the side. You know, we can't separate the x's and the x squareds, and then we have a number here as well, so we can't just divide across by x. It's pretty complicated. So here's the idea. Take a quadratic, and I've just chosen one with nice roots, so we have minus 2 and 8. And the way that we can solve it is, what if we didn't have a b term? So remember when we didn't have a b term, the bottom point was in the middle. So we can shift across a quadratic horizontally by taking the x value up here and subtracting a number k. Now, why do we subtract that number k? That's kind of a topic for another video. But basically, you can see if I make k positive, it moves us over to the right, and if I make it negative, it moves us over to the left. So, and we have to do that from every x value in order to shift it. Change the x's, obviously that shifts it horizontally. So now we have to just figure out what value of k will bring us to the middle. We can see here it's about minus 3, and then you can see this value is minus 25, lovely, because obviously then we have x squared minus 25, so our answers are minus 5 and plus 5. And then all we have to do is, well, this was moved to the left by 3 units, so we just have to move it back to the right by 3 units. So if we have minus 5 and plus 5, well, we just have to add 3 to both. So then when we shift it back, and this is the original quadratic now, because k is equal to 0, the roots are minus 5. Remember, we shifted across by 3, so minus 5 plus 3 gives us minus 2, and then we also had 5 plus 3 gives us 8. So you can see that's a pretty easy way of solving quadratic. So let's do the algebra and figure out if we can get a general formula. So let's say we just have a general quadratic, and we'll call it this. And let's move it across by k units. So you can see the roots of this equation are the same, except here the root is x minus k, and here the root is x, but the numbers in front are the same, so we'll get the same roots when we solve it. When you expand it out, then you get this, and we can group together terms. So you can see here's an x term, here's an x term, and these are all the constant terms here. And we can group those together. And now you can see, remember, we wanted the b term to be equal to 0. So that means we want this thing to be equal to 0. Now you might be thinking, if we make this term equal to 0, it's also very easy to solve, because if this term isn't there, well then we can just divide across by x, so 0 is a solution, and then there's one more solution. But the problem is, if we want to make this 0, this is just the same quadratic that we began with, except the variable here is k. So we don't know how to make this equal to 0. So that's why it's handy if we make this equal to 0, then imagine if this is gone, then we have x squared equals a constant, and we can just solve that very easily. And you can see if we want this to be equal to 0, that means that k has to be equal to b over 2a. And you might recognize that from the quadratic formula, negative b all over 2a. So you can see we're already starting to shape up a little bit. So if minus 2a k plus b is equal to 0, that means that this term is gone. And we know what this k is, and we know what this k is, because we know that k is equal to this. And then we can just solve for x, which is quite nice. So solving for x, you can see we get this, and we know what to replace these k's with, because we were able to solve for k earlier. So we can replace the k with that, and then we can expand it out, and we get this. When you square this, you square the top, square the bottom. We get a few nice cancellations. You can see this a will cancel out with this bottom a to just give us an a on the bottom. So we get this, and now it'd be nice if we got a common denominator, just because that makes it a bit easier. It gives us a neater formula instead of kind of square rooting all of this stuff separately. So we can multiply by this, because now you can see when we multiply this by 2, we get 4a, but we have to do it on the top, so then 2 over 2 cancels out, we're just left with this. And then same here, if we multiply top and bottom by 4a, it cancels out, we just have minus c overall. But now the denominator is 4a like these, and we can combine them all together. So then we get this, and minus b squared plus 2b squared, that'll just give us b squared when we simplify that. Now all we have to do is divide the a down. So when we divide the a downwards, so we divide this side by a, so over a, and we multiply this by 1 over a, and then you can see this will combine to give us 4a squared, and then these are gone. Then all we have to do is square root both sides, and here we can just square root the top and the bottom separately, so we can get x equals, and when we square root the top, we can't really do anything. Don't forget the plus or minus, because both answers will be valid things for x, because it can be minus x and it'll still work, over, and then the square root of 4a squared, well, that's the same as the square root of 2a, the whole thing squared, so this will just simplify to give us 2a, and we don't have to worry about the plus or minus, we do that on top. So here's our answer for x, but you might be thinking, what about the negative b part at the start? So now I might be thinking, how come this isn't the answer? What about the negative b? Well, remember that graphically what we're doing is we're shifting this across by a certain number of units. So we have to kind of undo that. And the way you can think about it graphically if you want, I'd encourage you to, but I don't want to give everything away. I want to encourage you to experiment a bit for yourself. The way I'm going to explain it is that the quadratic that we solved with this was this quadratic right here. And here, the roots of this quadratic you can see is x minus k. It's not just x, it's x minus k squared, and then x minus k, and then a constant. So the actual variable in question is x minus k. So this is just x. So in order to algebraically make it the correct answer, again, think about it as shifting in your own time, I would suggest. But here's k. K is just b over 2a. So we have to get x minus k as our answer. So here's x. Oops. Here's x. And we want to subtract k from that. And then because they have the same denominator, we can just combine it into 1. Get rid of this 2a. And then usually we rearrange it to put the thing on the left. So this is the root, even though it's x minus k, it's just the root of the equation. It's a minus b, bring it over to this side, plus or minus the square root of b squared minus 4ac all over 2a. And again, I'd encourage you to mess around with Desmos. I'll put the link to what I was doing at the start in the description. And I encourage you to play around with it and see graphically that we're shifting across by b over 2a. Maybe do some numerical examples, calculate b, calculate a. For example, here, remember we have to shift over by minus 3 units. And you can verify that, because remember our k value that we solved for algebraically was b over 2a. So b here is minus 6 over 2 times 1. So minus 6 over 2 is minus 3. That's where our k value comes from. So it makes sense. And yeah, that's pretty much it. So I thought this was really cool. I saw a YouTube video about it, but they only did the algebra. So I felt like I could kind of contribute by showing graphically what was going on as well. But if I find that video, I'll link it in the description as well.